So we have about 5 folks here. Sorry for all the commotion. I'm doing this for the first time, so I'm not really sure how it works, and it was not really playing nice with my webcam, so it took a few minutes. Uh, you can start adding your questions to the chat, and then I can answer them. Thanks for joining just at C. What's your question about? You said hi. What would you suggest? So for the first brand, right? I think like there are a few different things uh, that you need to take into consideration. So if you ask me, you can look at it from a perspective like what are you trying to get out of 3D printing? If you're trying to dip your toes, so you could be like you're just trying to understand what 3D printing is about, or you could be somebody who is really wanting to go into 3D printing, and you see a future in there either as a hobby or as a career. But in both of these cases, first and foremost, my suggestion is to go for Bamboo Labs. The reason being, when you start 3D printing, there are tons of issues that you don't know about, because it is a physical thing, right? If you do software, you know that like if you wrote 1 plus 1, you will get an answer of 2, right? uh, yeah, Tushar, I'll talk about like 15K versus 50K Bamboo as well in the same question. So essentially, what will happen is, let's say you have two options. You can either, and you're just looking at, say, an entry level printer right now because you just want to dip your toes into it first. So you have two options. You can either go for like, say, 13 to 15K any cubic, or like an Creality Ender 3, or the other option that you have as an entry level printer is a Bamboo Lab A1 Mini, which is around, let's say, 22, 23 K or something. So it's almost double. The difference that will happen in both of these places is essentially reliability. That's the main thing, right? If you took a Bamboo Lab, they have really mastered that. Like if you gave a print, right, 99% you are going to get that print done. So when I started, like I started with a Creality Ender V3, right? And essentially what used to happen is, after, let's say, every 2 or 3 prints, the next print would fail, because let's say when the it's moving along the axis, when the nozzle is moving along the axis, or let's say when the bed is essentially going backwards and forwards because it is a bed slinger. So I'll also talk about like what is a bed slinger and core XY printers. But essentially when these movements are happening, it is all in the physical domain, right? So there will be small errors that can happen. Now, what Bamboo Labs has done is like they have nailed that error compensation. That whenever this error is happening, like they know how to compensate for these margins much better. Like everybody does this, like everybody, all the companies know that there are errors happening and they try to compensate for these errors, right? But like they are essentially, like Bamboo Labs is much more accurate in this. The challenges that you will face is like if you got a Creality, you'll see, let's say after every 2 or 3 prints you have to do a bed leveling, but it is not really level, right? You will see a lot of memes around that whenever you have a challenge with the 3D printer, most of the times like the bed is not level. What that means is like if the bed is not level even for Bamboo Labs as well. But what it does is, like any 3D printer does, is it knows that like the bed is, let's say, 0.2 millimeter down at this point, 0.15 millimeter up at this point. So it'll try to compensate by moving the nozzle up or down around those areas. Bamboo Labs is able to do that much more easily compared to any other printer in the market today, right? So that's first challenge that you'll face. The second challenge that you'll face is that the parts that you have, right, you will find that like they are much more often they're getting like stuck somewhere. Let's say your printer, your nozzle is getting clogged more often in a Creality or an Anycubic compared to a Bamboo Labs. Or for example, let's say you have to change your rollers more often in a Creality compared to Bamboo Labs. So it's basically this, right? That what is the real reliability that is happening. The second, you can say a little bit more minor effect, which might not impact you that much as a beginner, is that the precision is also much better in Bamboo Labs. Let's say if you're creating a cube of 1 centimeter by 1 centimeter by 1 centimeter, what will actually get printed is not 1 centimeter by 1 centimeter by 1 centimeter in any printer, even including like Bamboo Labs. So there is something called a precision or a tolerance, which can vary from printer to printer. In Bamboo Labs, generally it is, you can say it can be as small as like 0.05 mm, right? And it can be as the maximum that I've seen, even without doing any kind of calibrations or anything. And it depends on like your filament and everything else as well. But typically, I've seen like zero point 0.1 to 0.15 in Bamboo Labs. In Creality or in Anycubic, that can be much more as well sometimes, right? So the precision will also be different in those printers. But that's as a beginner, if you're just printing, let's say, hobby kind of parts which don't have to fit with each other, right? It doesn't really matter that much. But you'll have to, as soon as you like do something else, you'll have to change your printer and get something more important, more, you can say, precision specific there. So I would say like that's the only reason why I would suggest that if you have to buy a printer today in the market, you can buy just like Bamboo Labs eyes closed. So you don't have to get that itch of that I bought this, now I'm done with this, can I buy something else? Plus you will be spending much less time like configuring like fixing your printer compared to any Bamboo Labs. Like when I got my Creality printer first time, I probably used to spend every 2 or 3 days, maybe like a couple of hours fixing some things with the printer. And maybe I printed probably 20 different mods like in the first month itself. So by the time I actually gave it away in like after 2 months or something, I had almost changed like 50% of the printer itself with aftermarket parts and aftermarket mods and everything else. So I would say like just go for something like 22K A1 Mini from Bamboo Labs. If you have a budget higher than that, like you can just buy something else again in the Bamboo Labs. They now have like something almost fitting every budget, like 22K for A1 Mini, 32 or 33K for A1. Then they have a P1S around 60K or something. Then they have a X1C, slight like a little bit higher than that, and then they have H2D. I would say like P1S is the most value for money, which has everything. But if you're just tipping your toes, let's just go for A1 Mini. Uh, I think like does that answer your question, just as C and Tushar there? Uh, you also asked a question, SKS 1290. I'll come back to your question. So, but first question, another question that I'll answer is resin or PLA. Which one you should begin with? I would say like it depends on what you want to do. They are two very different kind of printers. Uh, so PLA, or it's not like really a PLA printer. I would call it like a FTM printer, a fused deposition molding, right? So essentially, that in a FTM printer, the nozzle is moving around and it's depositing plastic like at different places on top of each other. That's why it's called like fused deposition. While in resin printer, it is essentially resin that gets into a place and it's gets hardened by exposure to, let's say, a specific type of light, right? And it keeps going on from there. The difference between both of this is, resin is much more, you can say, towards if you are into figurines, if you're into creating something of, let's say, decorative value. If you're printing, like you see those figures behind me, like the all might figure is there. So that's most probably, it's not something that I printed, but I like got it from somewhere. But that's most probably done by a resin printer somewhere. The reason being, it resin printer can do much higher resolution. You won't see any layer lines in there. You won't even find, like, you won't even think about like whether it has been done by a 3D printer or not, right? So it's much higher resolution. But the challenge that you'll see is, first challenge is, that it'll not be as strong as compared to an FDM printer. So in FDM you can use lots of different kind of material, and you can use lots of different kind of approaches, so you can make it very very strong, or you can adapt it to lots of different use cases. Resin also you can do it to some extent, but typically I would say that you should do it only if you're into figurines. The other, you can say, two other smaller challenges, one is slightly higher and the other is smaller, is the smaller one is essentially like it is much harder to do different colors in resin. So you would see that mostly people print resin in some neutral color like gray or something, and then hand paint it. In FDM printers, like you will find often that like you can switch different colors up to some limit, but like it is much more common to use different color materials and mix them there. But the main challenge that you'll face with resin printer is that it is highly toxic. Like fumes are always like injurious to your health, even in FDM printers as well. But in FDM printers, you can take care of some of these things. In a resin printer, you cannot really do it in a room at all, right? For example, I have my printer here, right behind me. So as long as I'm not printing, let's say ABS or ASA or those kind of things, I can have it in my room with the window open here, and then like I can be fine as long as like I'm not sitting in this room while the printing is happening for a long long time. For a resin, you should not be keeping that in this room. Plus resin would also take much more space, like in the FDM, like even though this is a large printer, like it is taking just this much of space. In a resin printer, you'll apart from the printer, you'll also need like a wash and cure machine, where you will wash the print after it, and you'll cure the machine as cure the print as well. So that'll again take up a lot more space, I would say like double this, even if you were going for like a basic one. So that's another issue. So that's something you will need to figure out, that am I going to go for resin or FDM. SKS 1290 can, for large scale application, could you be a little bit more clear about this question? I didn't really get this one, so I can get there. uh, Ashwin, you asked like, if answered before, if not answered before, what printer would you suggest for beginners? So yeah, I answered this question, Ashwin, but essentially my suggestion personally is to go for any Bamboo Labs printer. The lowest one starts from around 22K. That's what you should go for with. If you don't need an AMS unit, you don't need to buy it right away, and you can add this later on. But I would say that's a much easier entry into 3D printing, much more reliable. Plus, it will not give you an itch to switch it very soon. You can, if you really, really don't have any money at all, you can go for, let's say, a Creality or an Anycubic, and these they keep releasing like models every few months there, so you can look at like what is the latest one. I haven't been really keeping track of that, but you can buy something there. But I would definitely tell you that within a few months you will essentially want to switch it to a Bamboo Labs printer there, with the kind of issues and everything. One thing I should tell you though is like, it is not that like everything is lost on those printers. I definitely learned a lot more on those printers, because everything is so open that you can change like everything, every part. Like you can open it and you can figure out like what's going on inside the printer. It's much easier to do that. So that's a challenge that comes with Bamboo Labs, that once things go wrong, it is slightly harder compared to, let's say, a Creality or an Anycubic to fix those things. But my suggestion is just to go for Bamboo Labs. Like you will not face too many issues. And with a lot of people now selling Bamboo Labs in India today, you will be able to find those parts like very very easily. When I got mine, there was no reseller in India at all, except like one guy who imported this machine just for me around that time, and he was starting to get into it. And at that time there were no parts available, so I was a little bit worried. what happens in the future. But like I haven't had to replace anything at all in the last, say, 2 years or so that I've had this. Abhinav, you asked like how do you maintain the printers? In normal printers, they keep asking to take regular prints because the ink dries. So yeah, in a 3D printer, there is no such issue of that you have to keep printing. My printer, anyways, like it's almost on like every day, almost every hour. Where it doesn't generally matter for this. The main challenge for a 3D printer is like a wear and tear, because there are a lot of moving parts. Like it is always moving. So the challenge that you might see is that, let's say, a belt wore off, or a bearing like wear down, or let's say the nozzle is wear down, and tons of other challenges. Or let's say the two most common challenges that I face with my printer is, one is, let's say, the filament is broken somewhere. Right, it could be broken inside the AMS unit, which is basically the color switching unit at the top, or it could be broken inside some pipe, or it could be broken or clogged inside the nozzle. Right, so you might have to do it, like every printer has different ways in how to remove that clog. But it's typically for a very like when you're doing it for the first time, it might seem a little bit tricky. But I would say, like, once you've done it twice or thrice, it just becomes second nature. Besides that, the main maintenance is making sure that you're lubing the parts often. For example, every month or so, I lube essentially all the moving areas, like the bearings and everything else, for this printer there. One other thing is make sure that it is away from dust, or you're cleaning up the dust, so that essentially it is not creating friction, and again, like those moving parts. So just like any other machine where you will take care of the moving parts, like even like a bike or something, you'll have to do the similar kind of things here. The only difference is essentially it is at a much smaller level, so you'll need to have much more, you can say, carefulness while you're doing that. One small thing that you might need to do is, essentially, depending on the which kind of plate you're using on the bed, it'll often become oily, like with your finger, like when it is touching it or anything else. So your prints might stop sticking to it, so you have to clean it. It's pretty easy to clean that. Like you don't need to buy anything fancy. There are tons of fancy products in the market. You can, like, I just clean it with a regular unscented soap, any kind of like basic soap. You can use it and just clean it, and then it works. One tip is, like, typically with printers, often you may or may not get like a TPE like a sorry, I'm it's slipping my mind, like basically a special plate. So if you are getting, let's say, a Bamboo Labs printer, you might get like a cool plate, that they call it, or an engineering plate, where you have to put glue on it. Don't get those kind of plates essentially there. So you should get a plate where you don't need to use glue. With glue also it works, it's just like sticky and messy, and you have to clean your print after you take it off the plate. That's mostly it. In some cases, it might be possible that there is a lot of, you can say, work required. For example, one of the issues that I had with this printer once was that there was a blob which rode up the nozzle, and it was basically the filament was stuck everywhere. And you might face a challenge that, how do I clean this up now? So I have a heat gun with me, which I use for that. Like, essentially, you have to heat it up so that, like, it melts again, then you can clean it up. So you might want to invest also in a you can say special gloves which are nitrile coated, so you don't basically, you can use hot parts, like you can directly touch them and hold them while they are actually hot. But that's mostly about like maintenance there. uh, just let's see, you asked how to learn making STL files and edit files which we get online, cost of application for the same. Uh, so, so there are two different parts. If you're making an STL file from scratch, so you don't make STL files essentially, right? STL is a, you can say, a format which is sort of like, so there are two different things. One is a original design, which you call as, let's say, CAD, or something that you use, let's say, Fusion 360 or Tinkercad or something, tools like this, where you can create those designs there. So once you have created, just like, for example, you create like a 2D design in Paintbrush, you would create a 3D design in, let's say, Fusion 360, or you would like Tinkercad or something, right? And then after that, like once you are ready for printing, you can export it in a format which is basically what is called as STL format. So it could be STL or it could be step or something else, but ultimately the slicers use STL. So if I can probably like share my screen and show you a little bit there. So let's second. Yeah. So this is essentially Fusion 360. So here you will see like all of these tools at the top, right? So you would, for example, what you can do is very simple thing is, let's say you create a sketch, right? And let's say I create a rectangle here. It's very, very simple. Like what I did was like I just started playing with it and I saw a few tutorials whenever I have a problem, like how to do XYZ, just like you're learning any software or something, and you will find something and then you can go from there. And then what I'll do is I'll select it, I'll do E, which is for extrude. Instead of a rectangle, it is like a cube, right? And then you can do lots of different things with this to essentially create original designs. So you could do this and this, and there is another software which is very popular, which is Tinkercad. I use this because this is much more, you can say, powerful compared to Tinkercad. And also you will see in Tinkercad, let's say if you draw a circle, it will not actually come out as a circle. It will come out with ridges and everything. So just use this. The cost wise, essentially, if you're using for commercial, right? If you buy the commercial license, it is very expensive, but you can buy it, or you don't need to actually buy it. You can just use it on your own, and you can say that, yeah, I don't want to use it for commercial version, and then you can use it for free. There are a few limitations, like some tools will not be available, but typically you don't need those tools unless you are doing some large scale engineering work. Another challenge is, like, for example, if you see these on the side, these are all the ones that I'm working on right now, all the designs. This can be like only 10 at a time can be editable. You just have to, like, if you reach that limit, you have to mark it as read only. So there is some, you can say, uh, nagging way of like using them. So there is not a lot of limitation. You can just use Fusion 360 there. Another thing that you can do, after you're done with this, essentially what you would do is you'll export it as a mesh, uh, which is what you see typically on different websites, which is available like MakerWorld or Printables. What that happens is, like, those STLs you will essentially uh, take out, like, import into something called a slicer. So this is Bamboo Studio, which is Bamboo Labs slicer. Slicer is a software which takes these STLs and converts them into something called G code. G code is essentially instructions to the printer that move the nozzle to X location, move the nozzle to Y location, or move the bed by this much. Essentially, it is just XYZ instructions in a layman terms. So it doesn't know anything about the model. So it'll convert this STL into just those instructions that the printer understands. It's very similar to essentially how you write a code. Like, you would write software in, let's say, in C or in JavaScript or something, and then it'll be converted into, like, you can say, an intermediate representation of some language, right? Some binary language, and ultimately it will be converted into binary, essentially, which the computer understands. This is the same thing here. To Now, like, if you're creating your own designs, we talked about like how you can use, say, Fusion 360. But if you're trying to edit the online available STL, sometimes you will have CAD files available that you can import into Fusion 360. Most of the times you will have just STLs available that you cannot import into Fusion 360, that you cannot work on them easily. You can import them, like, but you will not be able to do the same things that I did, like just click on something and say, like, I want to extrude this by, say, 10 millimeters or something. You cannot really work on them. So you can use a software called Mesh Mixer, which is what I use often if you are modifying an STL file that you got from somewhere. uh, it will not be, again, as easy as working on, let's say, a CAD file, but it has tons of tools available that you can use in there. So remember these two tools essentially, either Fusion 360 or Mesh Mixer. I think these two are essentially which is going to be helpful for you. You can also do like some small kind of things in the slicer as well. For example, if I show you this slicer again. So for example, if I have to write a text here, so I can, let's say, select this and say text, right? And I can say hello, right? And I can put it here. So it'll have that hello here. Oh, let me move here. So you can like change its size and width and everything. Or for example, let's say you wanted to add some small cube, right? So you can, it has some things around like cube, cylinders, spheres, etc. There are some small things as well that you can add like an SVG image directly here, and you can do small operations on it. So if you wanted to, let's say, if you had, say, a logo in SVG for something like, say, Uber logo, you can just pull that SVG here, and let's say you can increase its size by 10 millimeter and just print that directly. So there are like some those things that you can do. So essentially, most of these things you can do either in Fusion 360 or in Mesh Mixer or use the slicer. For a slicer perspective, I typically recommend, if you're using a Bamboo Labs printer, either use Bamboo Studio or Orca Slicer. For any other printer, mostly use either Orca Slicer or Prusa Slicer. Prusa Slicer is the one that's made by Prusa, another company for 3D printers. But I think like outside these three, you don't really need to go anywhere. Uh, Next question is, what is the noise level with 3D printers? So they are generally very, very noisy. So this is why, essentially, for example, a lot of the printers have started investing into another, just like we talked about the error compensation, they have started working on noise compensation as well. For example, Bamboo has something called motor noise compensation and vibration noise compensation, because the machine is basically all just motors and vibration all the time, and you can even hear them in the next room when they're going on most of the time. And the faster they're going, like the more noise that you will actually hear with them. uh, Typically, I would say that if you are working on, say, anything with, say, this printer, or let's say even any other printer, it'll be hard if you're doing a video call right in the same room. You will probably not be able to do that in the same room because it'll be so loud. If you're trying to sleep, again, definitely you will not be able to sleep in the same room for sure if it is going on. You'll In a next room, probably you can sleep, but you'll still be able to hear a little bit. But the printers are doing a lot of work around, like, it can try to cancel out that noise by understanding like what is the kind of movement that will be happening in the motors, what is kind of vibration that is going to happen with the machine to compensate for that. But yeah, they are noisy for sure. Do 3D printers resume in the case of power cut, or is UPS needed? Most 3D printers these days, at least anything that is not entry level, will come with you can say power resume functionality. I think like even the basic Ender 3 these days comes with it, but I'm not really sure. But at least all the Bamboo Labs printers come with power resume functionality, so they will resume. But I still use a UPS. You'll see a UPS right there. I don't know whether you can see that below the chart. But I use a UPS. The main challenge being, because let's say if the power goes and the nozzle will stop right there wherever it was on top of the printer. Now the printer is stopped, but the nozzle is still hot. It'll take a few seconds, for example, for the nozzle to cool down. Till that time, it will keep leaking the filament on top of your print. So what's going to happen is that there'll be a small blob there, which can, at best, it can just be you can say a sore in the eyes, like it'll be a slight defect. In the worst case, what it can happen is it can change your layers there. So it'll create a small point where you can easily break that print. In some cases, if there is a power, you can say, outage, even though the printer will resume, sometimes you will see a layer shift. So the next layer that is printing, it is shifted by, let's say, zero point 0.2 millimeters or something. You'll see some artifacts there. So to avoid all of these kind of issues, I definitely suggest to invest in a UPS, which you don't really need to invest in a UPS to keep it going on for hours and hours, but at least make sure that you have enough where at least you can go and pause the printer so it parks the nozzle and doesn't like leave it on top of your print itself. That's a bare minimum, I would say, even if your printer comes with the power resume functionality. uh, Okay, next is Raza asked, best printer under 50,000 suitable for products like ESP32. Raza, I answered this earlier in the discussion, but essentially, buy anything from the Bamboo Labs stable. For your situation, I would suggest like A1. A1, because like A1 has a much larger build plate compared to A1 Mini. A1 Mini is around 22K and A1 is around 32K. Plus in 50K, in fact, like you can even buy the AMS unit along with the A1. Abhinav Verma, are you able to do the repairs yourself or a service place near where you live? I mostly do all the repairs myself. I haven't come across a service place yet for the 3D printers, at least in India. But I would say, like, essentially for most of these, ultimately you will develop enough confidence and enough, you can say, um, knowledge or know-how, that you will be able to do those repairs yourself. And there are tons and tons of any kind of printer that you take, like as long as it is a popular one, you will be able to find all kinds of videos online, like how to fix lots of different problems. One of the major benefits of like taking any of these printers is, any kind of problem that you'll face, for sure, like somebody else would have faced them somewhere. So far I haven't seen any kind of problem that I haven't found a video for on how to fix. So you'll be able to like do that. But essentially, yeah, you have to do most of these repairs yourself. I don't think like even if you take it somewhere to a repair shop, they would even know how to work with these 3D printers at all. It'll be asked how big of a space workbench is required to start with. Is it advisable to have workbench in a room you frequent? Fumes. So, for example, you can look at that small table. Like, you can even go smaller than this as well. So it is. I think like it is probably 3 feet by 1.5 feet or something. So you can even like the smallest table that you can have. The main thing that you need though is that it should be very very stable. That's the main thing, because the printer will move a lot, especially if you're buying something or like printing at high speeds. It is going to move a lot. If the table is not stable, like at best what will happen is the prints will not print that well, because the printer itself is moving too much, or in the worst case it might actually even fall off, like if it is moving too much. So rather than size, I would suggest like buy something that is very very stable. So if you see, like I've kept a ton of things at the bottom. The main reason is not to utilize space, but like the table is heavy, but also I wanted to add a lot of weight to the bottom so that like it remains in place, just for the stability there. And for fumes, definitely you would want to not sit in the same room for a long time, like if you are printing there actively. uh, so especially if you're printing anything other than PLA, like if you're printing ABS, for sure, like you can't even, I would suggest like don't even keep the printer in the room where you would typically work. Like just keep it in a very very well ventilated place. For PLA etc, it's fine to keep it in the same room, PLA or PETG, but don't frequent that room like too often. This definitely not in a bedroom, for sure, for example. uh, then the next is Subhashish, would you suggest Bamboo Labs A1 Mini for someone trying to start with? For yes, like you can also, after this call, you can look at the initial discussion that we did in the beginning of the call. So yeah, so Bamboo Labs A1 Mini is my recommendation for sure. uh, are LLMs like Claude and ChatGPT good for learning basics of 3D printing for beginners? Uh, I would suggest they can definitely help, but a lot of the learning for 3D printing is essentially just doing things. That's about it. And I would suggest like there are tons and tons of guides. Like Bamboo Lab Wiki itself is very good for the beginners, plus like a few forums. I think you can pick up like some of those guides there and just start printing, and that will actually help you learn much more than trying to learn from LLMs there. The LLMs, the challenge that I see is many of the times they will give you very, very generic kind of advice. And there might be smaller changes here or there that are not applicable to your particular case. They might be helpful for something. Let's say that, for example, if you're seeing lines on your prints, so they might tell you actually, for example, the filament might be wet, or this or for example you're going too fast, or the temperature is probably too much. So those kind of generic things, but you will again have to try all of these things out. So I would suggest like if you're trying to learn, just start printing and then just keep looking at problems and then try to search for those problems. I think that's going to help out much more than using LLMs there for those issues. Raza, which material is better for the exterior? For example, solar radiation shields in weather station, PLA, ABS, or a PETG. So there are two or three different things that you need to look at it. Right, one is the temperature itself. The other is like UV resistance. So I think like for PLA, definitely you'll face a lot of challenges. Like PLA, the temperature at which we call it like the glass transition temperature, like at which it will start softening out. So around 50 to 60, like 60 degrees Celsius or something, it will start softening out. So definitely like PLA is much harder to use in like outside applications. PETG is easier. PETG has resistance up to, let's say, 85 to 90 degrees Celsius. Plus, it has much more, you can say, UV resistance as well. So that's definitely something that you can use. This is my go-to. Best one is ABS. ABS has a very high temperature resistance, but I typically don't go for ABS mainly because of the fumes and everything. That it needs much more ventilated space, and it has much more issues compared to the PETG and PLA wherever fumes are considered. So I would suggest, like, if you are printing for a commercial purpose, definitely use ABS. Uh, Otherwise, PETG is good enough. I have started also using TPU in some of my prints. For example, like the things that I put in my car, where the temperature can be around like 80 or something, 70, 80. So TPU has been working out well for me. That's something that you can try. But depending on, like, TPU also has lots of different parameters depending on which kind of TPU you're taking. Like if it is 85A, 95, or what kind of softness, and which other additives are in there. So you might need to do a little bit of exercise in like what's working out well for you. But yeah, like PLA for sure, no. PETG maybe, like ABS for sure, you can use it. Ritik, as a beginner buying the first 3D printer, no 3D modeling knowledge, no tech background, what printer resources would you recommend? Same as what I've been recommending like many times. Go with like a Bamboo Lab A1, A1 Mini, or something like that's in your budget. You can look at, after this meeting, you can look at the beginning of the discussion where I discuss much more, but essentially like any Bamboo Labs printer. Uh, Especially like if you don't have that much of tech background, I would suggest like Bamboo Labs is much lesser hassles printer compared to most others. Nikunj, is it possible to work with metallic materials like zamag, alloy of zinc, aluminium, magnesium? Is it magnesium or something else? Sorry, I forgot my chemistry classes. Copper for 3D printers, or is one limited to plastics? So the typical 3D printers that you will find in the market, like for hobby use, they're all plastic, right? You can't really have metal printing with them. You need much, you can say, like several orders of magnitude more expensive printers for those kind of things. But what you can actually do is, like, there are two different things that happen even with a plastic. Like you have, like, visually they might look similar to, there are lots of different additives like people add into regular PLA or PETG to make it, give it you can say a copper like feeling or something else, right? So it might feel like, let's say, copper. So typically they call it like silk PLA or something. And in some cases they might actually even put some fibers in there, or let's say some metal, small, very micro particles in there, which might give it a feeling again about those things. So I'll show you, for example, this print. uh, So if you look at this Loki one that I printed, so it has like this shine to it. It might look like a copperish kind of a material, but it's actually just plastic. And this is again like a skull that I printed. It has like a gold sheen to it, but it's just again plastic. So this is what also happens a lot of times when you buy stuff from market. That is, it might be actually plastic, but they have just given it some kind of coating to make it feel like metal. Sometimes what you can also do is, like, you can print it in plastic, and then you can essentially put a layer on top of it, which might give you a feeling of, let's say, wood or plastic, wood or metal or something else. Even for wood, for example, there are PLA and PETG available with wood fibers in there, which might actually give it a feel of wood. Or you can just like put a layer on top of it, which is essentially like some kind of a chemical, which can form a small layer on top of it. What you can also do is, sometimes what I do is, you can just put a, you can say, wood, like a primer and a wood polish on top of it. So it will also give you a feel of wood there. So you can do like these different kind of materials feel even with plastic there. uh Sorry for an offside request, can you please create a tutorial as to how you host your website? Yeah, I'll probably create a separate one for that one. Yeah, I'll write it down. Raza, what's your opinion around the new controversy around Bamboo Lab firmware? Any other brand you recommend? Uh, I think, like, as far as that controversy is concerned, I'm not too worried about it. I think like if I look at it from a perspective of Bamboo Labs itself, they have to be able to protect themselves legally. Because let's say like last year, for example, there was a challenge where, or there was an issue like where their like Bamboo Labs printer started printing on their own, and a lot of people had some issues with there. Now, if a lot of people are like using their own kind of software instead of using Bamboo software, they can't really guarantee liability for this. So what they have done is like even now you can do many of these things that you could that were blocked out from their new firmware there. But what you have to do is you have to use their connect software, after which you can still use Orca Slicer or other things. So there are a few functionalities which are limited, but I can see from Bamboo Labs side like why they are doing it this way. There are ways to actually flash still like a aftermarket firmware with which you can do much more, but then essentially you are foregoing all of your you can say warranty and everything else. From a personal perspective, like I've been big, you can say, reverse engineer when I was young, and I would say like from that perspective it's definitely a limitation. But given the kind of convenience that they give me today compared to any other printer on the market, I'm happy enough with the current solution there, that I can still use Bamboo Studio, I can still use Orca Slicer if we need to, even though I have to jump through a few hoops, but I'm okay with that. So I don't see that that's a big issue there, uh, at least as of now. Any other brand you recommend? I would say that I think like besides Bamboo, it is very hard for me to recommend a brand. Like I'm a sort of a fanboy there, but I would say like Creality and Anycubic both are doing well there. Prusha has a lot of good printers as well, but they are much more expensive for some reason in India. I think like they don't have a probably an official entry route yet. Another way that you can do is you can do your own, build your own printers as well. Like Voron family of printers, essentially you can, like everything about them is open source, the software is open source, the hardware is open source, so you can get your own parts and build it yourself as well. So I would like say that if you are really into the mood of like going very very deep into the 3D printer technology and everything, you can just build your own printer. Otherwise you can look at like Creality or Anycubic printers for sure. But my recommendation would always remain, at least for the time being, would remain like Bamboo Lab. Why to like create too many problems for ourselves, like when there is something that is working out much better. uh, how did you start your 3D printing journey? So I basically had always thought about like 3D printing, like at least for the last 5 or 6 years. That yeah, I should do something. Like my typical thing was that for like whenever I'm trying to spend some money, like before that I would say that okay, I will read about it, I will do all of my research and then figure out a ton of things that how can I actually work on this, and then I'll spend my money there. So what I did was like around like 2.5 years ago or so, then I was not making any progress into that search at all. Like I was not able to understand anything at all. Like for example, the things that I was showing you in Fusion 360 or like the slicer and everything else, everything was just going over my head, essentially, like listening or seeing things like this without actually having a printer. So what I did was like I just bought like a cheapest possible printer available around that time, which was like a Creality Ender, I think like V3S Pro or something. So I bought that one because Bamboo Lab wasn't there anywhere around that time, and I just started with that. And essentially, with that, I could start understanding like what everybody's talking about. So I made very very rapid progress after that. Like within a month or so, I would say like I understood many of the things that were going on. I could make basic designs. I could fix a ton of things. So I think like it's not that difficult getting into this. For me, it was mainly the turning point was essentially when I bought the 3D printer and get got started. Once I started with it, like I could essentially not stop myself. So essentially, the main thing for me was like I could change everything around me. So I basically just kept continuing on that journey from there on. Have you seen a bump in electricity cost? Not that much. I think electricity wise, it doesn't really cost that much. Like Bamboo, for example, is one of the higher energy consumption ones out there. But even with this, I think uh, it goes up to, I think like 300 watts is the maximum that it pulls in. But there is a small caveat in there that I'll talk about. But like typically when it is running, it is using around like somewhere between 100 to 150 watts at a time. So not that much, like even if I use it almost all the time, maybe like 1,000 rupees or something. Like typically my electricity bill is around like 4 to 5 thousand or something, so maybe 20% or something. But this is when I use it a lot, like almost all the time at all. The caveat that I was talking about for the bamboo is, you will see beside the UPS there is something small greenish there. So in Bamboo Labs printer, the uh, at least in X1C, one of the challenges is like it's a directly heated bed. So there is no, it's heated from the AC power. So it heats up very fast. But one of the issues is that if you connect it to 230 volts, it can pull up to 1000 watts there. So which means that it would need like a power socket, like a 15 amp socket, which I didn't really want to use because I didn't have anything there. So I would have to route the wire and everything. So I'm using a step down converter from 230 volts to 110 volts, which is the American voltage. With that, it can go up to like 300 watts. And that's just, you can say, how their machine is designed. So that's one of the caveats that you might keep in mind there. But again, like that max power it takes in when it is heating up the bed before starting the print, which takes like a few seconds or something. So typically when it is printing around 100 to 150 watts there. uh, Ashwin, any YouTube channels you would recommend for 3D printers? Uh, I actually subscribe to a ton of them. I haven't seen just one which will give me a lot of knowledge, especially like with bamboo coming in. There are a lot of changes in there. I would suggest like just search for them, and I don't really have anything that I recommend as such. Is this is the typical one that you should use it? I think like one thing that I've done is like I, in fact, instead of using YouTube that much for it, I actually follow a lot of Instagram channels on 3D printing, which gives me a lot of, you can say, ideas there. Like one of the main things for 3D printing is like, besides anything that you can do, it's all about ideas. Like what are the different things going on? What are the things that you can do with them? For example, when I built this Winamp visualizer that you can see there, like it's blinking away. So this is an idea, like essentially that was brought out of like one Twitter comment, and also like because I had seen somebody printing something similar like that, they had, which they hadn't really done any electronics for it, but they were trying to recreate Winamp like on some Instagram reel or something. So on Instagram reels, essentially you can see this very quickly, and you can like swap through maybe like tons of them within say 10 minutes or something. So I was just like signing up to a lot of different 3D printing channels on Instagram. That's very, very helpful to get new ideas. uh, Raza, regarding the viability of 3D printers for industrial level applications and developing an IoT product that incorporates HVAC, and I intend to utilize 3D printed parts within it. Uh, if you I don't know whether Maher or Vishal are on this stream, but essentially even for industrial applications, I think a lot of the people are using the same like bamboo level kind of 3D printers as well. It is a lot about, I would say, like industrial applications. It's less about like which printer you are using. It is more about two or three different things. One is like your selection of the material that you're using, right? That whether you are using PETG versus ABS, and like what kind of, which, for example, companies, and what kind of specific parameters that material has. The second one is something called design for manufacturing, or DFM, that you need to design it in a way that you know will hold, you can say, true to your specifications. For example, when you talk about any 3D printed part, there are a lot of things that we talk about is the stress which will be applicable on it. The stresses could be, let's say, an impact stress, which is like this, like whether it will be subjected to impact stress, or is it like a shear stress. For example, if you have a column like this, will it have like this kind of stress or these kind of stress? Like these are called shear stresses. Or there could be like twisting stress or different kind of stresses. So you have to figure out, like, for example, let's say if I do 10 walls in here, it'll give a lot of, you can say, resistance to the impact stress. Or let's say that if I use this kind of infill pattern, let's say crosshatch or gyroid or those things, instead of like using a regular, say, rectilinear pattern, then I will get a lot of, you can say, resistance to shear stress. So those kind of things is what you are worried about. Plus you are worried about the precision again, like those things. So when I talked about the precision, you need to make sure that you understand what is the precision that is going to happen with the combination of your printer and this specific material at this specific temperature, and when it is actually used, like what is the kind of expansion that you can feel. So you, instead of depending on like randomness, you would design that into your design. Let's say that if you were trying to make a, like I gave that example in the beginning, that if you're trying to create a cube of 1 centimeter by 1 centimeter by 1 centimeter, it'll be slightly larger or smaller than this. But if you know all these specific, when you have done all this testing for your printer and you have come to know that, yeah, whenever I print 1 centimeter in say X direction, my printer actually prints 1.01 centimeter, right? So you would say that, okay, yeah, instead of printing, like instead of designing 1 centimeter, I'll design it as like 0.99 centimeter, so that yeah, when it actually gets printed, it will become 1 centimeter. So those things, like all of these like walls, etc., and like those things which is the printing parameters, like how do you design for your specific use, plus like which kind of material that you use, all of these things, like as long as you can take care of them, then you can take care of even industrial level applications in there. One thing that you should know is that 3D printing is uh, you can say uh, expensive as well, in some terms. It is very cheap when you're starting out, when you're just prototyping and everything else, but it is very expensive if you are doing a large scale, you can say, development for it. Let's say if you're selling say 2 lakh devices for yourself. So now for printing like the shells for those 2 lakh devices, it will take like years and years, because like the 3D printing will take a lot of time there, and it will cost a lot more as well. So you might as well, instead of that, like go for injection molding. Injection molded parts will definitely be much more reliable and much more, you can say, precision oriented as well. The only challenge with injection molding is like even just to get a mold done, you have to spend like some 2 or 3 lakhs minimum there, just to get the mold created, and then you have to get all the parts there. So it is only viable if you're printing tons of parts. But you can get started with 3D printers as long as you take the right kind of material and right kind of design specifications, and then you can go for it. One thing about design for manufacturing is there are a lot of resources available on the internet. So you should think, you should search for like DFM tutorials or DFM, just design for manufacturing. You will get a lot of knowledge from there. But besides that, like as you are trying out, you will figure that out yourself as well. One of the things that you should invest in is like this, uh, uh, vernier calipers, like a digital one, so you can essentially measure, like after you are done printing, so you can actually measure that, yeah, I had printed it for say 1 millimeter, but what is it actually coming down to, and you can see that number here. So you can actually like create some kind of intuition about like your specific printer as well. There are tons of, you can say, calibration tests also that are available today, that you can run, so that you can push in those parameters into your printing parameters, and it'll help to restrict like deviations as well. uh, yeah, Ayush, for anyone looking for help regarding their prints Reddit community. Yeah, I think like this is a very good comment. Like I think Reddit is probably my most frequented channels compared to any YouTube there. There is also one channel besides what Ayush mentioned. I think it is called Fix My Print. So where people just like post images of their print, that there is some issue that happened with my print. For example, yeah, this circle didn't come out well, or there is lines on it, or something like that. I'll mention that in the chat as well. My memory might be incorrect, so like it, but it's named something like this, Fix My Print. I think like, so you can go and post your print there that something went wrong, and people will figure out that, yeah, this is probably like the issue there, and you can try those things and they will try to help you out. But I think like even if you don't have any issue yourself, just frequenting these 2 or 3 kind of channels or subreddits will help you a lot. Yeah, Mayank, there is a meeting here. Yeah. Any other questions? Okay, I'll wait for a minute or so, and if there are no other questions, then I'll close that stream. but hopefully it has been useful for you. I think like if there is any other questions, do let me know. I think like this one was basically for the just for the beginners and introduction around 3D printing and everything. If you want any specific kind of things, then I can create like something around those as well. Maybe like if Fusion 360 or like just slicer parameters or design for manufacturing or something. Maybe we can do another live stream on those topics as well. शॉर्ट्स पे जो बॉटल से 3D प्रिंटर का स्ट्रिंग बनाते हैं, क्या वो वर्क करता है? आई डोंट फुली अंडरस्टैंड मयंक, आप क्या कहना चाह रहे हो वहाँ पे? इफ यू कैन गिव अ लिटिल बिट मोर आइडिया। व्हाट्स योर मोस्ट कॉम्प्लेक्स 3D प्रिंट? आई थिंक probably this one. Let me try to take it off. So I printed this kind of a desk mount, which is like a modular one. So you can see like basically you can create, you can add hooks, you can add this uh, kind of different kind of attachments here. You can take it out, take it off. There is a cable management tool here that you can again take it out, and all of this you can basically put anywhere around this area. So it had a lot of precision and tolerances issues there. Plus, because it has tons and tons of different attachments that I made, like these are just two or three kind of attachments I made, probably like 15 different kind of attachments for this. I was thinking about like putting it on the store as well at some point, but like there's so many different attachments, I didn't really want to deal with like figuring out all the combinations and everything for the orders. But I think like this is probably one of my most complex ones so far. Do you take a custom print order? Right now I don't have the printer. I do, but not always. Like depends a little bit, Raza, if you can send me a message separately, because I do this mainly as a hobby. So it depends on the model itself, plus if there are modifications required or not, plus if I have the time or not. So there are a lot of different kind of variations that go on. But I'll let you know, like for example, if I can do it or not. Otherwise I'll suggest, like there are other people as well who do some of these things at a commercial level, so I can help you connect to them as well. uh, DigiWizKid. I am from CS background, recently picked up OpenSCAD, found it into. Yeah, OpenSCAD is great. Like I think like essentially if you are from a CS background, right? Because it is, it basically is code is, creates your code, converts your code into physical dimensions. So it's really, really great as well. Plus, like you can do a lot of more, you can say parameterization if you're using OpenSCAD or those kind of things there. So I think like it's pretty great for those. So I had printed something recently. For example, if I show you this, so this is something that is done in OpenSCAD, where like essentially this is like a numbers which you like come out like this. And then what you can do is instead of designing just this, for example, 2025, it's a code where you can essentially like add any number or any kind of any text there, and it'll convert the same thing through code. So I think like OpenSCAD is great. I think. Thanks, Ashwin. Thanks for joining as well. We'll definitely share more. ओ कोला बॉटल से जो लोग 3D प्रिंटर का मटेरियल बना लेते हैं, अच्छा. So I think like there are some things around where people melt. So जो filament रहता है, that is basically just plastic, right? But I've seen a lot of people like in bamboo labs printer, what happens is like you will see a lot of waste filamental coming out. I've seen people actually do that, like you can melt that plastic and again convert it into something usable, but you need a special machine to convert it back to filament, because the filament needs to adhere to again very close specification, like 1.75 mm is the diameter of that filament that needs to go into printer, and it has tolerances essentially around like 0.02 mm or 0.03 mm. अगर इससे थोड़ा सा भी छोटा बड़ा होगा, then it basically your printer is going to get clogged. So I've seen people do it. It needs a specific machine. But as far as using a cola bottle there, I am not really sure, because cola bottles and all of these things, because they need to use PETG, because PETG is food safe. One of the main things that you should understand is PLA can be food safe, but PETG is definitely like food safe, as long as like again like you need to make sure that it is not touching any other material, it's not used for any other things at the same time, and a lot of precautions. But cola bottles are essentially PETG, but like we had talked before, PETG has much higher temperature resistance. So it'll need some special machine to essentially actually melt it down properly and then make that material again. I personally don't know anybody who does it at home. So maybe like, but I'm pretty sure like industrial level it can be done for sure. Mayank, I think like that would answer your question. Okay. Okay. I think we are almost at 1 hour mark. Thanks everyone for joining. And like I said, like just let me know any questions that you have either here or on Twitter, and we can answer. आपने कुछ मल्टीपल कलर प्रिंट किया क्या? Yeah, all the time. I think like if you see, for example, that Spider-Man which is hanging there, that's something I designed a while back. That's multicolor. That eyes that you see there, like that's again something that I designed. That's multicolor as well, and like tons of other prints as well. Yeah, which brand filament that should use? So I use mostly, so Sunlu is the brand that I use mostly. So there are, I would suggest, like for example, there are few different materials available in the market. Typically, you should look at like what is the, again, reliability of that material, and like what is the strength parameters. Like you will find all these specs whenever you look at the material, temperature resistance and everything. So if you look at, let's say, PLA plus example, right? PLA is like your lactose acid. I forgot that name, but essentially PLA plus means there are some additives in there. The manufacturer will mix something in there. That something is basically a secret sauce. Not really secret, but essentially everybody does it in a different way. So PLA plus doesn't mean the same thing everywhere. So what will happen is from manufacturer to manufacturer, that quality will differ a lot. And for me personally, I found that the top brands available in the Indian market for this is Eason and Sunlu. Bamboo Labs is also available now, but it is like almost twice the price compared to Sunlu and Eason, with slightly higher quality compared to that. Again, so Polymaker is another good brand, but again, it is very, very expensive compared to these two. So Eason and Sunlu is what I recommend typically. There are Indian brands as well. For example, New Makers is very, very famous. Plus, there are new ones coming up like every day. New Makers is slightly cheaper. If you are buying, let's say, a 1 kg roll of a PLA Plus from New Makers, that'll cost you around like I think 950 or something, including like shipping, taxes, everything. If you buy Eason, it'll cost you somewhere around like 1200 to 1300 from Robu. Sunlu, you will find somewhere around like 1300 or so, or as well. So there is a difference about like 300 rupees between the two. But I find that Eason and Sunlu have a much higher reliability, as well as like temperature resistance and strength characteristics compared to the New Makers one. So if you are like, but New Makers is not bad for sure. If you are on a very, very tight budget, you can go for New Makers. I don't think like I've found any other Indian brand which is as good as New Makers yet, but I haven't tried too many there. uh, but if you can stretch a little bit, Sunlu and Eason are very, very good. I used to use Eason earlier all the time. Now I don't use them because I use this AMS machine, right, which has all of these four, up to four colors that you can put in them. Eason switched to cardboard spools. And cardboard spools you can't use directly in there because it spreads dust, the cardboard dust inside it. So I had to like print adapters for it so that it can move easily and doesn't leave that dust and everything. But I got fed up with it, so like I started using Sunlu there. So yeah, brand wise, Sunlu, Eason, or New Makers you can use. With my top recommendation being Sunlu, then Eason, and then finally New Makers. Do you own a filament dryer? I store my filament in Ziploc bag. Until now, it's been fine with PLA, but PETG sometimes shrinks. Yeah, I do have filament dryers. I have like an old Eason one, and recently, then I bought another Creality Space Pi one. So basically, I can dry up to three spools at the same time there. For me, it is a must. Bangalore is very, very humid. I live in Bangalore. It is very, very humid. Like right now, I think a few days ago, the humidity was around like 73% in my room. So essentially every material gets very, very brittle very, very soon. So yeah. I also don't like, I used to use Ziploc bags earlier, but I have moved to like airtight kitchen containers, where essentially it is slightly easier to use and slightly better than Ziploc bags there. If you are living in a, you can say, a relatively drier place, you might not need it. But if you are seeing stringing and everything, yeah, definitely you should use a filament dryer. If you use TPU, then for sure you'll need to use a filament dryer. TPU is essentially very very quick at absorbing moisture, even if you're in a relatively dry place. If you can't invest in a filament dryer, you can try to do it within your printer itself. Like if your printer is enclosed like this one, so you can like set the temperature to some value and then like let it do it, but it'll take a long time. Or you can invest in something like a food dehydrator. So that's also something that works, but you need to be a little bit more careful about temperature selection and something. In the filament dryers, like those will automatically happen for you. Arun, if possible, maybe you can print something for us in the next live stream. I can, but like the printing basically takes a lot of time. So noise part I can take care of. For example, my mic essentially cuts out all the noise, so you won't hear anything. But it'll take essentially like hours to print something. But maybe I can print something small, which takes like 10 or 15 minutes or something. Then I can do that. Yeah. Cool. Awesome. Thanks a lot, folks. I'm happy that you guys found this useful. And yeah, let me know any other questions. Thank you. Bye bye.